Two more topics remain in section 5.4. The first involves the transpose of a matrix. This is obtained by switching the rows and the columns of a given matrix A, and it's denoted by A superscript capital T. That's transpose of T. So if we're looking at the matrix A with row 1, 1, 3, 5, negative 2, and row 2, 6, 4, 0, negative 1. We're going to transpose this. We're going to make row 1 become column 1 and row 2 to become column 2. So what would this look like? So I'm going to take my row 1 and make this a column now. I'm going to make it go up and down. So now I have 1, 3, 5, negative 2. I've got the same entries, but instead of it being a row, it becomes a column. Same thing for row 2. I'll have 6, 4, 0, negative 1 becoming my column 2. And so instead of having a 2 by 4 matrix, I now have a 4 by 2 matrix. 4 rows, 2 columns. And then finally in 5.4, the scalar product. This is the matrix obtained by obtaining each entry of A, by multiplying each entry of A by a constant, which we usually call C. If you read the textbook, it will describe it as C. So in example 1, it asks us to find 3A. This means that we're going to multiply 3 by every entry in the matrix. So our matrix is 3, negative 1, 2, 0, 1, 4. And we are going to multiply each number by 3. So 3 times 3 is 9. 3 times negative 1 is negative 3. 3 times 2 is 6. 3 times 0 is still 0. 3 times 1 is 3. And 3 times 4 is 12. And this is our scalar product, 3A. And then we can use this concept to solve more difficult problems, such as finding 3A minus 2B. We're putting together the scalar product and subtraction. So first of all, we need to find 3A and 2B, which we've already found 3A. Copy that down here. And then we need to find 2B. For 2B, we're going to multiply every entry in B by 2. So that's 4 times 2, which is 8. 2 times 2 is 4. 2 times negative 1 is negative 2. 2 times negative 2 is negative 4. 2 times 0 is still 0. And 2 times 3 is 6. And now, so I've got my 3A and 2B. Now we just have to subtract the two matrices. And we said we subtract matrices by subtracting the corresponding entries. So this is going to be 9 minus 8. That's A11 and B11. 9 minus 8 is 1. Negative 3 minus 4 is a negative 7. 6 minus negative 2 is a positive 8. 0 minus a negative 4 is positive 4. 3 minus 0 is 3. And 12 minus 6 is 6. And so our matrix 3A minus 2B is a 2 by 3 matrix. The first row is 1, negative 7, 8, and the second row is 4, 3, and 6.